Today's lesson 6.4 is all about rectangles, which is the shape I'm assuming we have some familiarity with. So the basic things you already know, we'll review those and then look at some properties that we will be able to utilize to find missing things. Starting out, definition for a rectangle that you will see on your test in another week and a half is that a rectangle, it is a parallelogram, so all that stuff that we've been working with for the last two periods would apply. It's got two pairs of parallel sides that are congruent, the opposite angles are congruent, the consecutive angles add up to 180, and the diagonals still bisect each other. So everything that we said was true for a parallelogram is also true for a rectangle. So you still have all of those properties at your disposal. The thing that makes the rectangle unique, in addition to being a parallelogram, it has to have 4 right angles. So that's the extra requirement. And since it has right angles, kind of a reminder, if two lines intersect at a right angle as such, that means that they're perpendicular. So if they're right angles, they've got to be perpendicular to one another. And this means that the slopes of the adjacent sides are negative reciprocals. The slopes of the adjacent sides are negative reciprocals. And we'll kind of review what that looks like real quick. Slopes of the adjacent sides being negative reciprocals would mean, like we worked a couple chapters ago, if one of them is positive 3/4, the other one is going to, instead of positive, become negative, and instead of 3/4, it becomes 4/3. And that's something on the assignment. If it asks you to check to see if it's a rectangle with the slope formula, you're going to find the slopes, just like you would have done on the last assignment. And instead of just checking the opposite ones to see if they're the same, you want to check to see if the ones that would be next to each other have that negative reciprocal relationship. A little visual. Go ahead and sketch a rectangle. And then we can mark it up that that angle, that angle, that angle, and that angle are all right angles. So we have rectangle, it's got to be a parallelogram, so it has all the properties that we've been working with for the last week. In addition to that, all 4 angles must be right. And like any parallelogram, the opposite sides are congruent. So this side would equal this side would equal this side. Again, every single angle is 90. If I were to draw the diagonals in, they would still bisect each other. So we would have that this is equal to this, and that this is equal to this. So that's kind of review from last time as well. In addition to that, instead of just the diagonals bisecting each other, if a parallelogram is a rectangle, then its diagonals are congruent to each other. So if it happens to be a rectangle, the diagonals, in addition to bisecting each other, are also congruent, so they're equal to each other. This fact can be used to determine if a parallelogram is a rectangle as well. So on the assignment, if it asks you to use the distance formula to figure out if it's a rectangle or not, you would figure out how long each diagonal is, and if the lengths of the diagonals are equivalent, then it is a rectangle. It's a little visual here. Go ahead and sketch this one. And we'll label this as X, Y, W, and Z. So if I draw in the 2 diagonals, from X to Z and from W to Y, those have to be congruent. So this whole thing would equal this whole thing. So we could just write that XZ is congruent to WY. And then going a little bit further, we said that they still bisect each other. So normally just this half equals this half. But if this whole thing is equal to this whole thing, then this half would also be equal to this half and that half. So that's a property that's unique for rectangles, that instead of just the halves that are on the same line, all 4 of them are congruent to one another. And with that, we are ready to start solving for some missing things. So for example 1, go ahead and write quadrilateral STUR is a rectangle. And again, kind of just a word of caution, make sure that we are not making assumptions about what things are. If it doesn't tell you it's a rectangle or you don't have some evidence of that, you shouldn't be able to use those properties. But in this case, I'm just telling you that's what it is, so we can use all those properties. And we're going to get this drawn, and then we're going to label that angle RSU, I'm giving you that one is 64 degrees. Angle RSU, so trace from R to S to U, so that is this one, is 64 degrees. And what I want us to do on this example is I want us to fill out every other angle here. So there, the 4 here, and the 2 in each other corner. Okay. So again, our goal is we're going to fill out every other angle that is unknown, which we can do as long as we know at least one of them. And there's a few different places you could start. One thought that kind of stands out to me to begin with is we just said the parts of the diagonals, that this is equal to this, which is equal to this, which is equal to this. And that would mean that if I look at it a little bit, such as in this area, if I just look at that, there's 2 equal sides, so that's an isosceles triangle, which means those are the 2 legs, which makes SR the base, which means angle S and angle R are base angles, and we remember probably that the base angles are always the same. So that makes this 64 degrees as well. And then because this triangle and that angle would be congruent to that angle, by side, angle, side, this triangle on the left would be congruent to this triangle on the right. So that means that this is 64, and this is 64. And then we could do what we've done before to find these 2 vertical angles here. If I know that those are 64, we could add those up, get a sum of 128, and then we're remembering that the angles in a triangle have a sum of 180, so we could take 180 minus 128 to figure out that left over would be 52. So that's going to be what this one is. And then because those are vertical, that one's also 52. So figuring out the other 6 total. One thought I've got is if it's a rectangle, we know each corner has to be 90. So if we know that part of each corner is 64, we could do 90 minus 64, and that gives me 26. So that would tell me that each of these other parts, that's 26 degrees, that's 26 degrees, that's 26 degrees, and that's 26 degrees. And then the last 2 we want to find are here and here. Lots of ways we could do it. What I'm thinking as I look at this is, well, there's a line, so that means the 52, and what I want would be a linear pair, and linear pairs add up to 180. So if I take 180 minus 52, that'll give me 128. So that would be what these last 2 would be. 128 and 128. We could have, if anybody was thinking about it, because we have another triangle down here on the bottom, we could have thought about using the 26 and the 26 to find 128. If you add 26 and 26, you'll still get that 52, so it ends up working out the exact same way. So at that point, we have found every missing angle in that rectangle. And that's something that you'll be expected to do. So a lot of it is using skills from previous units. And there's a lot of different things you can think of, like here, if that's 26, we could also reason that that had to be 26 because they're alternate interior angles, which comes up there. It also comes up if that's 64, that's alternate interior, so that would make it 64. We thought about it in terms of isosceles triangles and linear pairs, so be conscious of just all the different things that we have going on, and then use that to fill in all those gaps. So if any of that didn't make sense, feel free to pause it and then rewind it and then rewatch that example. I'm going to go ahead and move on though. Example 2, give you some time to write down. We are going to kind of extend what we just did and then merge that with algebra. So we've got rectangle ABCD. So I'm telling you now, this is a rectangle. And I've already drawn the two diagonals, AC and BD. And those intersect it. So to begin with, we're going to think that DM is 4x plus 2. So as usual, it's a good idea to label that. This part here is 4x plus 2. And MC over here is 2x plus 10. And our goal is to figure out AC. So like usually it plays out this way. Before I can find that measure, I'm going to need to figure out what x is. So our thought is what we had earlier, that in a rectangle, all of these parts are the same. Which gives me an equation. If these are the same, I could set them equal to each other. 4x plus 2 equals 2x plus 10. Solving it, move the 2x over. Get 2x plus 2 equals 10. Subtract the 2 over. And 2x equals 8. Divide by 2, and x will be 4. And then we're not done yet, because we still want to figure out what AC is. And AC is this entire length there. So I need to figure out what that is. So our thought could be that if we want AC, well, what if I figure out MC? So I'd take the 4 and plug it in. 2 times 4 plus 10 would give me 14. And if MC is 14, actually there's an error there, isn't there? Let's fix that. 2 times 4 would give me 8. 8 plus 10 would give me 18 instead. So if MC is 18, then AM would also be 18. And to get the whole thing, we could add those parts together. So if we do 18 plus 18, we would get as our final answer 36. So again, if any of that wasn't real clear, I would pause the video, go back to it, watch it again, and then hopefully that helps out. I'm going to go ahead and move on to figure out the angles. What I'm going to do at this point is just go ahead and erase some of the stuff that I'd marked up there so there's not too much going on in the picture. And we've got angle DAC, so tracing that out. D to A to C is this angle, and I've got that it is 4x plus 10. And then over here, angle BAC, this one is 2x plus 20. And I want angle ACD, so I'm just going to put a question mark there. So the thought that I've got, those two are not equal. And I get that's going to be something that we're going to want to do, but those two are not equivalent. What is true, though, since it's a rectangle, every corner equals 90 degrees. So that would mean if I add those two together, 4x plus 10 plus 2x plus 20, we know they're going to have to combine to give us 90. So we're going to combine like terms, get 6x plus 30 equals 90, minus the 30 and get that 6x is 60, divide by 6 and get that x is 10. And we want angle ACD, and I don't have anything there, but my thought would be ACD would be the same as one of these up here, and it is going to be the same as this one. Because those two are alternate interior, they're going to have the same measure. So if I want angle ACD, I could find angle BAC. And we do that by plugging in. So we're going to end up doing 2 times the 10 that we got, plus 20. And 2 times 10 plus 20 would give me a final answer of 40 degrees. And a simple way to check myself, if I plug 10 into the other one, if I do 4 times 10 plus 10, that gives me 50 degrees. And then I can really quickly check, okay, if that's 50 and that's 40, if I add 50 and 40, the result's 90, like it was supposed to be. So everything checks out. So again, the difficulty is right when you're getting started, you have to make sure that you choose the correct equation. Sometimes things are going to be equal. Sometimes we're going to do what we did here and add them to equal 90. Sometimes they'll add to 180. You've got to make that decision based on what they are. Final example is going to be one of the coordinate style proofs that we've been doing lately. So I'd recommend at this point that you go ahead and pause the video, take some time to write this down, and then unpause it when we're ready to start working it out. Quadrilateral J, K, L, M, N has vertices J at negative 2, 3, K, 1, 4, L, 3, negative 2, M, 0, negative 3. And we're going to determine whether J, K, L, M, N is a rectangle by using the distance formula. So first step, we are going to graph this. So sketch a coordinate plane. And we're just going to plot the points. So I've got J at negative 2, 3. So negative 2, positive 3, there's J. K at 1, 4. L at 3, negative 2. And last, M at 0, negative 3. So right there on the y-axis. So then do your best to connect that. And visually, you know, my graph's not perfect. It looks like it might be a rectangle. And might be doesn't matter. We're going to have to do the distance formula to figure it out for real. If you're working with the distance formula, we're going to find the lengths of the diagonals. So that would be JL and MK. If when we find the lengths, they're the same, it's a rectangle. If no, they're not. In case we need a reminder, the distance formula, like we did last couple classes, x2 minus x1 squared plus y2 minus y1 squared. And like I said, JL and MK are what we have to work with, the diagonals. So we're going to work with J and L together, and then likewise K and M together. So let's start. So let's do JL first. Square root. If we're looking at J and we're looking at L, the x's are 3 and negative 2. So I'm going to do 3 minus negative 2. And when I subtract a negative, I make it a plus. Squared plus, now look at the y's. y2 would be negative 2. Minus y1 would be 3. Evaluate. 3 plus 2 gives me 5. Squared gives me 25. Negative 2 minus 3 gives me negative 5. Squared also gives me 25. And then add, and we get square root of 50. And then getting the other one, we're going to work with K and M. So exact same process, just those other points. We would do 0 minus 1 plus negative 3 minus 4. Zero minus 1 squared is 1. Negative 3 minus 4 is negative 7. Square that and you'll get 49. And 1 plus 49 does again give me root 50. So at that point, I'm noticing that I got the same thing on both of them. So when it says determine whether it's a rectangle, if you get the same number for each diagonal, then yes, it is. Kind of like last time, these will be worth quite a few points. This one in particular, you would get 4 total, 1 for the graph, 1 for each of the root 50s, and then 1 for correctly identifying yes at the end. So like the other examples, if we didn't get that down or it just doesn't make sense, pause the video, go back, rewatch it. And that is the last thing that I wanted to share with you today. So the assignment's going to get passed out now. Practice that, and then it'll be due when we meet again, which for you all will be Tuesday. And there will also be a quiz on Tuesday just over 6-4. And that will be the last grade that we have before Thanksgiving break.